Hello everyone. Today I'll be talking about virtualization and hypervisors. In this presentation, I will explain what virtualization is, why it matters, the different types, and how hypervisors play a key role in this technology. So, what is exactly virtualization? In simple terms, virtualization is the process of creating virtual versions of computing resources like servers, desktop, or network using software. This means a single physical machine can run multiple virtual environments independently. For example, one physical server can host several virtual machines, each with its own operating system as if they were separate computers. Virtualization is crucial because it maximizes hardware usage, reduces infrastructure cost, and simplifies system management and recovery. It's also the foundation of modern cloud platforms like AWS, Azure, and Google Cloud. For instance, before virtualization, a company might need 10 servers for 10 different applications. Now, one powerful server can host 10 virtual machines, reducing cost, space, and energy consumption dramatically. Here I am showing the visual representation of virtualization categories. Now let's see the five main types of virtualization: hardware, software, storage, network, and desktop. Let's go through each one with example, starting with hardware virtualization. This is the most common type. It uses a hypervisors to create multiple virtual machines on a single physical host. Each virtual machine behaves like a real computer with its own operating system and resources. Examples are VMware ESXi, Microsoft Hyper-V. Here you can see the real-life example. On one physical host server, a hypervisor creates isolated, independent virtual servers. This allows a single machine to simultaneously run completely different operating systems, like a Linux application server, a Windows server with IIS, and a custom OS with a database, all securely separated. This is the foundation of cloud computing efficiency, and the reason platforms like Amazon EC2 can serve millions of users simultaneously. Now, what is software virtualization? Software virtualization lets one operating system run inside another. It's very useful for developers and testers who need multiple OS environments. Examples are Oracle VirtualBox, VMware Workstation. And the real life example is a developer uses a single host machine like a laptop running Windows or Mac OS and installed virtualization software such as VMware Workstation. This lets them run multiple operating systems at once. For example, a Linux setup, an older Windows version, a new Windows version, and Mac OS all on the same computer. Now, storage virtualization combines multiple physical storage devices into one large unified pool. It improves flexibility, backup management, and scalability. Examples: VMware vSAN, Ceph, Logical Volume Manager, and the real life example is um, instead of managing individual hard drives, a storage virtualization layer like VMware, vSAN, or Ceph takes petabytes of data from many physical devices and combines them into a single storage pool. This pool can serve different needs such as virtual machines, database, file shares, or analyticals data. Now, network virtualization. Network virtualization allows multiple virtual networks to operate over the same physical hardware. It helps improve performance, segmentation, and network flexibility. Examples: VLANs and VMware NSX. Let's see the real life example. Network virtualization is how large cloud environments keep customer networks separate and secure. A network virtualization layer such as Google Cloud VPC sits above the physical network hardware. It creates isolated, software-defined network for different customer or even different environment within one organization. For example, a developer VPC for customer A production VPC for customer B, and a secure remote access VPN for customer C. All of these share the same physical infrastructure, but the virtualization layer ensures they are completely isolated and protected. Now, we have desktop virtualization. Desktop virtualization allows user to access a desktop operating system remotely from any device. It's great for central management, data security, and remote access. Examples: Citrix Virtual Apps, VMware Horizon. Example is desktop virtualization in education. Universities uses desktop virtualization platforms like VMware Horizon or Citrix to deliver specialized desktop to students remotely. Whether a student needs an engineering lab setup, a coding environment, or a science simulation, they access the same virtual desktop streamed securely from university servers. This enables equal access for all students, even from personal devices at home. Now, let's talk about the most important component, the hypervisors. A hypervisor is software that manages multiple virtual machines on one host. It allocates resources efficiently and ensures isolation between VMs for performance and security. You can think of it as the brain that controls how virtual machines share the same physical hardware without interfacing with each other. Now, let's talk about the two main types of hypervisors, Type 1 and Type 2. Type 1 or bare metal hypervisors are the powerhouses of virtualization. They are installed directly on the physical hardware with no operating system underneath. The hypervisor manages all the hardware resources and divide them among multiple virtual machines because they are fast, secure, and have minimal overhead. They are used in data centers and cloud platforms like AWS and Azure. Type 2 or hosted hypervisors are the ones you usually find on personal computers. They run on top of an existing OS like Windows or Mac OS and manage virtual machines as applications. They are great for developers and students who need to test different systems, though they run a bit slower since there's an extra layer between the hardware and the virtual machines. Now, the summary. Virtualization allows multiple systems to run on a single physical machine, improving efficiency, scalability, and cost effectiveness. Hypervisors make this possible by managing and isolating these virtual machines. And across all five types, hardware, software, storage, network, and desktop virtualization, this technology continues to power the backbone of modern IT and cloud computing. In real-world use, VMware ESXi is widely used in enterprise data centers. VirtualBox helps students and developers run multiple operating systems for learning or testing. Cloud providers like AWS, Azure, and Google Cloud rely on custom-built hypervisors to manage millions of virtual machines securely and efficiently. We are also seeing AI-driven hypervisors which automatically optimize performance and predict overload demands. Thank you, everyone. This was the presentation about virtualization and hypervisors.